From 1900 to 2015, humans have caused a direct increase of nearly 100% in the global atmospheric carbon dioxide concentration, causing a net increase in mean global temperature and climate variability. According to the U.S. Environmental Protection Agency, these changes are a result of burning fossil fuels and a lack of carbon sink preservation, ultimately resulting in harmful amounts of carbon dioxide. The EPA writes, human activities have contributed sustainably to climate change by adding CO2 and other heat-trapping gases to the atmosphere. These greenhouse gas emissions have increased the greenhouse effect and caused Earth's surface temperature to rise. Processes such as deforestation, reforestation, desertification, and urbanization often contribute to changes in climate.
The removal of Earth's forests not only decreases the number of primary producers that can recycle the excess carbon dioxide, but also increases the rate of a positive feedback loop associated with Earth's polar ice caps. As the average global temperature rises, the area of the polar ice decreases proportionally. These rapidly melting ice caps act as giant reflectors of the sun's ultraviolet rays, returning massive amounts of solar radiation back out into space. Therefore, as ice area decreases, so does the amount of sunlight reflected out of the atmosphere. This adds even more heat to the greenhouse gases, expediting climate change in an exponentially increasing positive feedback loop, also called the sea ice albedo climate feedback mechanism.
Researchers from the University of Maryland published similar climate change predictions for the Tennessee area while also stating the likelihood of a grim future for Tennessee's outdoor agriculture. Climate change causes an increase in temperature and precipitation. Precipitation variability is one of the most important components of agriculture. Unfortunately, infrequent yet intense storm events will not maintain adequate and continuous soil moisture for plant survival.
Climate change leads to variability in precipitation and temperature. This variability will not allow us to sustain consistent crop yield. Without an abundant and predictable crop yield, we will not be able to provide food for the population. With such increased risk of massive crop failure, one solution lies in creating a system in which species of native plants are grown in a low variability indoor system. To grow enough biomass to help sustain a population, this model needs to be below ground level, away from intense temperatures, precipitation, and pests. To ensure proper protection from extreme conditions, the system must be vertically stacked with a library shelf type arrangement of the crops. The crop bed positioned upright allows for extremely large growth density per area space and can receive light energy from solar power sources, powered by a solar circuit when arranged in parallel. To combat the variability of a constant water source, the implementation of wind-powered water storing system, which is utilized by farmers in the Trace region of southeastern Europe. The water system, powered by local wind turbines, transports water to storage devices across this region's mountainous terrain, which is very similar to that of Hamilton County, Tennessee.
We would like to fill the need for local, sustainable food with the opening of a subground urban farm in the heart of Chattanooga. Using the latest indoor agricultural technology, such as turbine-powered water sourcing, we will provide a year-round supply of organic, fresh produce which can be sourced to the community. We will create a community kitchen where produce can be purchased at subsidized prices. This kitchen will also offer cooking lessons with the intention of teaching community members what to do with the produce at hand. Through partnerships with local government and business, such as the City of Chattanooga and companies like EPB and TVA, we hope to supply the community with the resources they need in a sustainable way. Inspiration is taken from projects such as Better Life Growers and Plenty, the vertical grow startup company out of Silicon Valley, California.